Okay, so continue part 2, unit 3, and we will continue to study preventive maintenance. So, so the next thing that we consider is the cost, and cost is really important in business. Manufacturing is a business. Maintaining the system by doing a maintenance costs money. Okay, so that we have to take a look at. So how do we calculate arrangement? To check, right, return on investment business. So you check your ROI, return investment, obligation is on. First thing that we check to calculate the cost in the plan and invest a maintenance program. Okay, you don't want to spend so much money for it. Okay, usually calculated to be than the repair and breakdown cost. And usually I already taught you how to calculate by using the failure rate, reliability rate, and then you can be able to use the mean downtime, right, and mean time of failure. And also the Q, so all of that in unit 2, okay, to come up with cost calculation. So if your equipment failure does not interfere production capabilities, then preventive maintenance is not to be necessary. So that's how we determine whether we so you take a look at failure, and if that failure is not going to interfere production, don't have to put so much investment in benefits for that kind of system. So it depends on kind of action you are doing in business. Okay, so when you take a look, you see the 2 years data, number of failures. This is the number of for failures. And we're taking a look at 20 failures, right? So altogether, if you add, I have 25 months, no failure, 6 months, failure, 7 months, 2 failures, 3 failures, and then 2 months. Okay? So they different times. So one failure is going to cost you $708. So if you have like a 20 breakdowns in the past 20 failures, it's going to cost you $30,000. Okay. Now I have, how many failures do I have? 10 failures I have. Okay. 2 years. In 2 years I have 10. So you add 7, 8, 9, 10. So let's calculate the expected breakdowns. So calculate by using this equation. First, you're going to get the sum of the product of the number of failures and frequency divided by total frequency. So that's the number of expected breakdown, okay, the weighted monthly average breakdown. So expected breakdowns, we're going to use a table data. So 0 failure in 5 months. After 6 months later, from this point, I have, after 7 months later, from this point, I have 2. After 4 months later, from this point, I have 3. 2 months later, from this one, in a total of 2 years, okay, I have 10 failures. So that's the sum of failures time is frequency. divided by total frequency is 24. So you will get the expected breakdown divided by 24, and it's equal to 67 failures per and some students have issue understanding the frequency because it comes in months, right? And we're talking about the time right here, right? 20 months. There's a 5 months, 6 months later, 7 months later, 2 months later, and you have that number of failures. So don't stress on being the you just go with, if you have issue understanding frequency, you can just go weighted monthly average for breakdowns. Okay? Sometimes when you take a look at you, because of the way they all it, it makes you think like this isn't time, right? This makes you think like this is failure, number of failures, and that's a total number. So I see that some of the students using 10 right here, right? It's just a 10 failures. So that they look like that's a number of failures, not. Okay? It's just a way that formula is written in this book. Funny, right? I wouldn't say frequency for this. I would just say go with month, right? Total, and then here use a time factor instead of this. So anyway, so make sure you can also skip right from here to there. So I just want to make sure that you understand these are months and then these are failures. It's divided by the total, so you will get the monthly average breakdown. Yeah. So don't stress on this one. So 40 by 20 is equal to 1.67 failures per month. So that's a rate breakdown. So out of 20, right, you get expected breakdown, okay, 1.67 per month. So expected breakdown of 40 divided by 24. Frequency is telling you like, okay, in 7 months you have 2, so 7 times 2 is 14, right, expected breakdowns. So every 7 months, all right, getting 2. So that's how expected. So expected cost, we multiply 1.67, right, the rate times the cost. So 750 for each 67. Be spending $1,252, right? 50 cents. Yep. So let's assume first exam for the preventive maintenance program. In that program, we're spending $900 per month. And we've been doing that for 12 months. So you need to understand failure is still, it can happen. So every time there's a, it doesn't say like it is going to happen. It's only say like there's a chance of failure to happen, right? And that's come from prediction again. So keep in mind the failures still do occur and can happen and generate causes. So in addition to the fixed cost of the PM, if you have failure, you're going to spend $750 for that failure. Okay, so you have a regular cost running the PM, and you have cost to repair if the failure happened during, alright, the preventive maintenance period. Okay, period meaning time. You're running 12 months PM, and you spend, alright, 900. If you have a one failure, you spend $900 plus 750. So in this table, we have 0 failure in the first 10 months, and we have 1 failure in the next 2 months. Okay, so therefore in total, frequency of month is 12. So here, times, so 2 times 1 is 2, 0 times 10 is 0, so you have 2 divided by 12, yeah? So that's your expected breakdowns. So how much should the company be willing to pay per month maintenance program? Is it okay with 900, right? As we do it 12 months. So now PM program, we're running it for 12 months. So there have been 10 months, but no equipment failure. 2 months, all right, on equipment failure. We're going to start to calculate the total failures, number of failure times the frequency of your month. So 1 times 2, 0 times 10 is going to give you 2 plus 12. 2 divided by 12 is 0.7. So that's the average, your rate failure per month. And we're going to multiply that with $750 for, so you will spend 127.50 failure. And then we're going to add our regular APM cost is $900 per month. So when you add it, you get $1,027.50. And that's 1 month PM and failure that happened. So this is the average monthly cost breakdown since instituting preventive maintenance program is only $1,027.50, right? That's what failure 0.7. So without the PM, okay, if you don't run the PM, you're going to have to pay $1,252.50 compared to failure. So therefore, save about $225 per month, right, to run preventive management, right? So times, this is over 12, right, times 12 is your profit. So in this example, example 2, every time of a failure in the system, to repair that is going to cost the company $6,000. But it will cost, right, for the company only $20 per preventive maintenance, alright? This is routine pay $120. So in this system, the mean time of a single failure is 150 hours, and we run this system 2,000 hours per year. Year means 12 months. Okay? And this system is running without the maintenance 96,000 hours in a year. When you take a look at the graph, you see this little black line right there, and that just showing you the cost of not having a maintenance program. Okay, that is 96,000. So that's 80, that's 1,000, that's 96,000. So let's do calculation to see if that's meaningful to run PM this rate. The cost for having no PM is equal to the cost per failure time expected number of failures per year. All you have to do is number of failures that happen in a year times the cost for each failure. Yeah? So we can calculate that by first calculating the expected number of failures per year. So in 1 year, we operate 2,400 hours. We will have a failure every 150 hours. That's the mean time of failure. You divide that, you'll get 16 failures can happen, right, in this system without preventive maintenance. So one failure will cost you $6,000 right here, times 16 failures in a year, and you get $96,000, right, dollars. That's what here. So now we think about preventive maintenance. So preventive maintenance cost line is determined using reliability, right? So you have to calculate at what reliability that you run your system. So number of annual PM that you have to do for this system, we're running 2,400 hours per year. And preventive maintenance frequency, okay, is 8. So that's that comes from the desired reliability at 5% failure, right? That means you're running the reliability a 95%, right? Because 5% failure, so 1 minus 0.05 is going to 100 minus 5, yeah, 95% reliability. So in this example, they said at 5% failure risk and 95% reliability level, you're going to have 8 preventive maintenance frequency. 8. You have to do KPC for that operation hours. So 2,400 divided by 8 would give you 300, all right, number of annual PM. So the annual PM cost is going to be, you have to pay 120 per PM. So we have 300 in a year. So you will spend 36,000 to run the PM for a year at this reliability percentage. So the cost of failure, okay, with management. So number of PM per year, 300 times 1 minus reliability, okay, is 0.05, which is 5%. And the cost per failure, we spend one failure to repair that or maintain that is $6,000. Okay, you will be spending $90,000. Okay, and that is running the PM, and you have one single failure will cost you $90,000. But this again, failure usually it doesn't happen. Okay, So it is pretty rare that you will be spending $90,000 if you have the regular preventive maintenance program running, because usually we can prevent that failure. So therefore you don't have to spend, alright, repair costs for that in the system. So this is, we usually calculate to the worst case scenario, okay, to see what's the maximum that can happen if you have one single failure. If you have 2 or 3, then that totally, okay, no good, and you have to eliminate the program right away, immediately. What we're targeting is this routine, and you will never have here in the system by doing this routine at this cost. Okay? This is only a calculation, a prediction if in the worst case scenario our system failed a single time with preventive maintenance program, you would spend this much, but this is still way below the normal repair without having any kind of management. Preventive maintenance management. So again, I show you this little error that's given to you, and usually in a table, so you don't have to that. And for the worst case scenario calculation, usually come with a single failure that can happen with the preventive maintenance program going on. You can calculate this way. Okay. So here it's a table you usually get, and there is a variation. A failure risk from 5 or 5%. Your reliability is really good high here, so reliability very low there. Failure is going up, so reliability will go down. So you want to keep your system around here. So here, reliability, see, really high and going down according to the it's right there. And this is a calculated preventive maintenance frequency that you have to do in order to maintain that reliability and the cost. And this is a computer generated calculation for you. So here the total cost of preventive management is equal to annual preventive management, a cost of 36,000, and the cost of failure, already previous slide, it's 90,000. So it will cost you $126,000. And that is with prediction a single failure that can happen PM. And that's pretty high, the highest you can see for highest reliability. And if you keep the reliability at 80, you will be spending only 90. If you usually American company reliability is 65 to 60, okay? So you spend 78 to 82 there. So it will always be less than low maintenance cost of $56,000. Okay? And usually, again, this cost usually don't happen if your preventive maintenance is working. We can definitely prevent that failure. Yeah, this is just a prediction, worst case scenario, with the highest reliability that we calculate. But in real life, it's always around here. Some of the company go to the 45 to 65. So that's the amount that we spend. So this minus that is the amount you're all saving, okay, doing PM. Do not get confused by looking at only this first row, alright? That's just calculation with a real and realistic reliability of 90% in the system that never happened, okay? and the highest that you can see by calculating it. This is a computer generated calculation. It's about the same. This is a hand calculation. So the total cost of PM, okay, that's from table zoom in the USD 126,000. So the preventive maintenance cost line is determined using various desired level. So this is an extreme case of 95%. So return investment for the PM is because of the increased productivity. Okay, so if we stretch our system to go up high in reliability, we spend that much of preventive maintenance cost, but it's always worth it, okay, because you are getting that much of reliability in your system, which is generating millions and millions and millions of dollars profit. Okay, and we can use that money to cover this so easily. See that? So your profit is not 126,000 and comparing with that 96,000 with that the preventive maintenance, all right, cost. Your profit return on investment is by spending this much, maintaining the system reliability that much. How much money are you making that production system? And that is your profit. You don't decide by looking at, I would be spending 126,000 and I have a single failure, so I'm just going to go without preventive maintenance and let the system cost only $96,000. No, 96,000 is just for repairing the system. Your loss is while you are repairing, your system isn't running, okay? And that time cost and the loss of that reliability in your system is reduce the company profit in the market. And that's your loss. Okay, that's your loss for ROI, decrease in ROI comes from that. So therefore, even if it costs more, alright, in this case, preventive management with the extreme 95% reliability, single failure that happen. You cannot compare that expense to the profit you will be making out of that system. Okay? So the ROI PM is because of the increased productivity and improved quality. Okay? Overall equipment effectiveness and a better customer service and a more pleasant work environment and so these are all our ROIs by spending this much of money system, we can maintain that much of reliability to make millions and millions and billions of dollars in ROI. So after the money, all of this, okay, after the good production reliability level, you will get all of this automatically. Okay? If a system is running well and making good product, and everybody is going to be happy. Okay, so the discrepancy between 126,000 and 131,000, that's the machine generated and that's the human handwriting calculation, is due to the computer used, right? The actual frequency hours is 7.69, not 8. Okay, so our human calculation, we just go with the 8. Computer in the program in your machine, they're calculating with 7.69. That's why you have discrepancy PM expense. Yeah, I just want to point that out. So this problem is going to be in your midterm and also final exam. So make sure you study that. Okay, that's the end of this part.